Good morning. Thank you for joining me for this presentation. So my name is Juliette Rambourg, and I'm part of a very special team that work on the OnBoard, a interactive large surface designed for teamwork and flexibility in surgical flow management. So when we think efficiency of hospitals, we firstly think about surgery outcomes, of course, procedure time, the performance of the surgeons, or imaging quality. But how many people here, how many of you have ever experienced delays waiting at the hospital, maybe for surgery? Yes, yeah, well, at least in the US, many people do. So could the hospital organization be as efficient and as punctual as the bullet train in Japan, right? That's a good question. So in a surgical suite, there are actually many operating rooms like this, and they share resources, which are staff and equipment. And their management is done in a coordinated space, which is usually in the corridor. So the organization of the whole surgical suite has a big impact on the waiting times and on the overall surgery's outcomes. So if we zoom in on this central corridor where coordination and scheduling is made, you have different space, for instance, the board runner front desk, individual computers where staff can do personal work, and also a big whiteboard on which is written the whole surgical schedule. And you can find this in all surgical suites you can visit. So here you have a zoom on the whiteboard and how people work on it. So key activities in the surgical suite are scheduling the cases, rescheduling them, allocating the surgical staff, and more crucially, reacting and adapting the schedule according to contingencies, according to emergency people you need to perform surgery on. So it's a collaborative activity involving many people with different roles, nurses, surgeons, anesthesiologists, board runners, we talked about them, transporters, and cleaning crews, very important. So the whiteboards are the hub of the surgical suite where the staff meet and collaborate. They are a semi-public, large, and very flexible collaborative surface which result in a shared awareness of the surgical suite status. The problem is those whiteboards are manual and they are not up to date, right? This hinders context awareness and the dissemination of information, leading to all these delays and probably a lot of errors that could be avoided. So the traditional answer to not up to date is computerization, right? So if you look at computerization of hospitals, computerization and automation of processes are usually conventional solutions to support research management. You have here a word cloud from an important article on computerization of hospitals by Himmelstein in 2010. So he estimates that so far hospital computerization has not brought any evidence of improvement in administrative cost nor quality, neither overall cost. It has brought only modest improvement on the quality of patient outcomes. And the only computerizations that have brought quality improvement were actually custom-built systems in-house by the users, by the physicians. So if you take electronic whiteboards, for instance, you have here a handful of these you can find in literature. So Rasmussen reports in a literature review of 21 electronic whiteboards for the surgical suite that the problem stated is that they deteriorate information accuracy, they are inflexible, and even more importantly, they turn a staff collaborative tool into an administrative tool. So our hypothesis is that usable and flexible interactivity tuned to local particularities of the surgical suite can create a working environment in which the medical staff can cope with unexpected events and become the owners of the technology, appropriate the technology. So following this hypothesis, we developed OnBoard, which is 84 inches multitouch surface, vertical orientation, that was so designed to support the surgical flow teamwork. So OnBoard belongs to a larger cyber-physical system, including activity sensors that are in every operating room of the surgical suite that give you the real-time operating room status. But we're going to focus in this presentation on OnBoard, the interactive part of this cyber-physical system, how we build it, and how we deployed it in a real surgical suite. So to design OnBoard, we selected methods that are focused on the users, the physicians, the nurses. We use participatory design workflow, and technology probe approaches to gather information and redesign on-the-go features with the users during the deployment. So we established the requirements of the system. You have here the list. I'm not going to detail each of them, but for instance, if you take requirement 6 to appropriate technology, which is very important for surgical staff, the OnBoard system should allow users to continuously create and adapt new work practices, because practices evolve also as new staff come in and new cases appear in the surgical suite. So in this part, I will present the different interactions you can have with the OnBoard. So you have here, on this video, you can see the large multitouch surface with 2 users. So it's placed in the corridors that you saw on the picture earlier, which is a semi-public and central area. It's a place of information sharing and verbal communication. So if you take the layout, it was kept very close to the traditional whiteboard because it answers most of the design's requirements and design principle we established. The central area is a succession of mobile updatable line representing the surgical cases. So here in part A. In part B, staff assignment area. I'm going to detail this later. And in the top part, a toolbox to support addition of cases, adding magnets, etc. So if you focus, if you go to the detail of a surgical case line, all the information necessary to deal with this patient during the day is written on this line: operating room number, start time, patient name, procedure title, etc. So all this information, according to contingencies, according to the turnover, can be changed in emergency, or people have to plan ahead. How are we going to make this work? How are we going to make the surgical flow efficient? So first, we want to support interactions that already exist, so changing this information. So to change the start time, you have here an interaction where you press on the time and you have a clock and you drag the hand of the clock to choose the new time. Here you have how to change the OR number, same thing with a simple drag and drop interaction. So what I want to emphasize in these 2 interactions is that once you have made the modification, once a user has made the modification, the font that is used to display the number turns from a computer font to a handwritten font. That signifies that a user made the change and not an automatic change from the computer system. Here you have how to add alert magnets, just like people were doing before on the traditional whiteboard. They had magnets to signify, for instance, a latex allergy on this example. And then so you have a computer, so you want to bring a richer support. So here you can move the cases up and down according to how you want to reorganize the cases according to each other, which is something that people could not do before. They had to erase the whole case and rewrite it if there is a room. So it was really a big pain for the users. Here you have an interesting interaction that is just shifting a case on the side. So visually, you extract the surgical case from the whole flow. You can tell visually there is something different about that case. We didn't really have any idea in mind of how this feature would be used. We wanted to let the users show us what they would use it for. So we're going to talk about this a little later. A very important feature, I did an emergency case. So sometimes you have the scheduled surgeries and you have a patient coming from the ER. And so you have to add him in the flow. So you drag and drop, same thing like a magnet. Oh, it's not playing anymore. Too bad. You drag and drop the magnet and you open a new line, a new cases that's empty. And according to how much information you have, you can fill partially or fully the case. Yep. And on this one, it's how to delete a case, because when the surgery is finished, you got to get rid of the line to make room. So we wanted to focus on error prevention, because this is very critical to delete a case if the patient is still in the operating room, right? So you have to drag and drop through all the bubbles until the trash to actually say, yeah, I really, really want to delete that case. So it's a little... so here you manage the staff. So you have magnets that represent people. So they wanted, for instance, a little avatar with them here, a bald eagle. So the staff Montero, medical doctor, drag and drop the representation to the operating room he's associated to. Handwriting, so like on the traditional whiteboard, and for the sake of flexibility and technology transition, we really wanted to preserve the ability to write and erase on the electronic board. So this fosters a requirement 6 appropriation of the technology. So you can write with a pen with whatever you want and erase with 2 fingers interaction. So it can be fingers, it can be also we modified a dry eraser to perform this interaction. And so finally, we want to enrich the information that's on the board, so via the sensors we talked about earlier. So on a case like this, the sensors will show you the status of the case, so through timelines that appear simply like this. So the problem is sensors detect the operating room status, but for now we don't know which patient was in the room. So we had to make do with this. And so we developed this interaction, which is mobile timeline, so which is the operating room status, but you can actually move it on the case that you as a user, you know this is this patient that's in the OR, and you move the timeline. So these features show how we can compensate with interaction from deficiencies from an automatic system. And finally, of course, first question was, why don't we make a smartphone app that can connect to it? So we did build a smartphone application where you can pinch and drop a case on your phone and carry it with you within the hospital. So the deployment part, we were lucky to be able to deploy the system in the surgical suite. So it was OnBoard was installed in Fondren OR surgical suite right next to the whiteboards of the surgical suite, as you can see on the picture. And the sensors were installed in the 12 operating rooms of the surgical suite prior to the study and connected to the whiteboard, the electronic board. So that's the map with all the sensors and the board. So the surgical team of Fondren comprises 124 people. So a lot of people work together, and during the deployment we worked closely with 2 anesthesiologists, 2 board runners, and 2 nurses. First result is the participatory design of the board was done with a team that was different from the team we deployed the system with. And still we had good results. Even if they share the same goals, every surgical suite has their own culture and specificities. So we had to do some minor customizations, such as adding a couple magnets and making staff magnets for them, as this is what they use on their whiteboard. So the surgical staff was able to perform their daily activities like rescheduling cases with OnBoard as designed. And we got interesting comments. A nurse commented, "I love this electronic board because it is very close to my whiteboard, and I love my whiteboard." They don't really want it to be removed, but they understand that they have to computerize the system, to link their whatever collaborative tools they use to the hospital system. So they think it's a good approach to take them in account in the redesign of computerization. And finally, it has a good property because we were able to show them the real-time status of the operating room on the board, which was the purpose of the cyber-physical system. Finally, handwriting fosters flexibility. These interactions support actions that were not planned by the designers. For instance, here, the surgeon name was input wrongly in the computer, and so the users just scratched it and wrote the real name of the surgeon that was supposed to take care of this patient. So that was a way to compensate an error in the system via interaction. And finally, the shift the case interaction was immediately, the board runners immediately took it and said, this is how we're going to put a case on hold, meaning this case is out of the flow. We have to wait further information on this patient. So that was, and so the final result we wanted to communicate on is the collaboration. So the deployment, during the deployment, we could foster synchronous and asynchronous collaboration among the surgical staff. People would gather in front of the board, exchange information on the patient using the board as a support. They would take notes or make modifications themselves. And there is the other aspect where the deployment was a way to support collaboration between the staff and the designer team. via proposition of customizations or new ideas of features. A lot of ideas were proposed, such as if you want to make a double of staff magnet, you could press it and it would make a double of it. So it was very nice communication on the design. So to conclude, we implemented OnBoard as a large interactive surface, offering usable and flexible interactivity, handwriting, mobile timelines, partial modification, tuned to local particularities. So here's the surgical suite of 400 operating room. And so that's resulted in satisfying computerized support to perform the surgical suite management activities and foster appropriation of the technology. For instance, usage that were not planned by the design team, but that users could still perform. So thank you for joining me for this presentation. Please ask me any question. I'm here to answer.
Okay, so if you have any questions, please state your name and affiliation and ask it.
Thanks for this talk. It's really, really interesting. I really like the fact that you redesigned. So thanks for this talk. So it was really, really interesting. Really like the fact that you actually design with practitioners, with people that are really operational, so nurse, anesthetics. And so what lesson did you learn while actually collaborating with these people and with in the design of the system?
Yeah, so something I will always remember is at first, the first reaction of people in the hospital when you tell them we're going to add a computer is people are not happy. It's already a lot of computers there, and they have their own, culture and habits. And so the first reaction is no. But then, you include them in the design and they start to understand, okay, this is actually built with us, for us, and so we're going to actually be able to make a difference here. So that was a lesson. We really showed that if we include the users in the design with user-centered design methods, the outcomes are really better, because at the end, these users let us install OnBoard in the surgical suite, which was something that was really unclear at the beginning of the project, because it's a critical environment, the surgical suite. The life of people are dealt with, so nobody wants a big disruption in the flow. So by working with them, we're able to design interactions and an overall layout that satisfied them, and they told us, okay, we think we can deal with the flow and in this environment.
Thank you.
Hi, Stacey Scott, University of Guelph. First, thank you for the great talk. I thought it was very interesting. I have a ton of questions, but I'll read the paper for technical detail or talk to you later. I have a question, I guess, generally about process. How long did it take to develop the system through how many iterations, and where is it in terms of deployment, and is it still in the hospital being used? Okay,
so yeah, we made, I think we would say, 3 major iterations on the software itself, according to the users' feedback when we would do the test with them. I would say to have a good stable version, because users are not very available. Like, they work, and when you take on their time, they're either losing money because they're not working, either they're asking their boss to take time off. So it took time, and so I would say after a year we were able to have a nice stable version. But we installed it in the surgical suite in May this year, so 2.5 years after the very beginning of the project.
Thank you.
Make it very quick.
Okay, sure. I'm Leila Humayan from the University of Waterloo. Thanks for the great talk. So my question is that, was the digital board, was it multi-touch? And if yes, did you observe people using it simultaneously, and what were your observations?
So you mean multi-user usage of the board at the same time?
Interacting with the wall at the same time.
Yeah. So using the traditional whiteboard at the same time was not done that much. I mean, you would have maybe 2 people writing at the same time. So we allowed this with OnBoard. 2 people could write and erase at the same time. We did not observe it too much. We think they did it because at the moment we would tell them you can actually do it, but they would, let the person finish, and then I'm going to do it myself, because they, confidence in the system has to be built, and they were probably unsure that they could use it at several people at the same time, maybe afraid that it would freeze. Or we installed it for about a month, and so yeah, you need time for people also to get used to it and accept.
Okay, thank you.
Yeah.
Okay, let's thank our speaker one more